Hello everyone, welcome back to the next video in SQL Server. Today we are going to learn about what is normalization in SQL Server. So, normalization and denormalization are a process involved in SQL Server databases to avoid redundancy of the data and manage tables efficiently in your database. So, normalization is a process which can be used in our database to reduce the redundancy and dependency of your tables. So, it is typically involved in decomposing the tables, so breaking up a large table into smaller tables which ensures that it will not be any dependencies and there won't be any redundant data are the duplicate data which is repeated again and again in a table. So normalization is just breaking down a big table into small consumable and related tables. So denormalization is combining small tables to improve the query performance of your tables. So let us see a deep analysis of what is normalization and the use of normalization and what are the types of normalization available in SQL Server and how we can use that in live queries. So let us get into SSMS to understand more about database normalization. In SQL Server, the normalization can be defined as 1NF, 2NF, 3NF, up to 6NF. This is nothing but NF is normal form. So we can break down our tables, a large single table, into multiple tables to manage and avoid the redundancy in our data and avoid the duplication. So it will be easy to manage for us. So what is a 1NF? 1NF is also known as a first normal form. So a first normal form is usually known as a table that does not contain any duplicates and all the values in the table are an atomic value. Atomic value is in the sense it cannot be divided further. So the value in the column for the table is unique and there won't be any repeating groups or array contained in the column. So if a table is in such a way, then it can be said as a first normal form. So what is a second normal form? So if a table satisfies a first normal form, then we can also take the table for a second normal form. In the second normal form, we can break down the table entirely into a different table. So we can ensure that all the non-key columns are fully dependent on the primary key. And in the third normal form, we can reduce the transitive dependencies available in your table for the non-key columns. So let us see some examples so you can understand this better. So now I have a table called a table with multiple call. So let me first select this. Let me first uncomment this. So now let me execute this. In this table, you can see I have an ID, department name, employee 1, employee 2, employee 3. This table shows that in the department marketing, I have 3 employees, but I have a duplicate column. So if a table need to be in first normal form, you don't have any repeating columns or a duplicate columns. So in this table, you can see the employee column has been duplicated. So this may causes redundancy for our data, or it can allows the table to have anomalies in it. Anomalies is a false value that can be avoided if it is a normalized form. So here is another table which is a table with. So in this table you can see I have a ID, department name and employee name. So this is same like the previous table, but in this table you can see for the employee column I have a employees but an array of employees. So I have 3 employees in the marketing, but I have all the employees in a same row, so separated by a comma. So what causes an anomaly? So if I need to update a single person, let's say for example I need to update the Jane Smith in this marketing table, then it would be so much difficult for me to update such values in this table. So to make these two tables as a first normal form, we can create a table like this. So let me show a modified table which we have created. So here we have the same ID, department name and employees, but here you can see there is a marketing row and the respective employees has been separated into separate rows. So this shows the table cannot be break down further, that is all the columns have unique values, so there is no repetition of duplicate columns, and also each row contains a single value which can be easily updated. So now if I need to update this Jane Smith, I can use the ID2 and update the value. So while comparing with the above two tables, we can see the third table is in a normalized form. So this is what the first normalization is. The table must not contain any duplicate columns, and all the values in the table must be in an atomic value. So let us see what is 2NF further. So for this, let me create this employee courses. So now let me insert these values inside the table. So 8 rows got affected inside the table. Let me select this table. Select start from the student course. When I execute this, you can see I have a student ID, student name, course ID, course name, instructor. So here you can clearly see I have a student ID and their respective student name and the course that they have enrolled, and for the course ID we have a course name and a respective instructor. So here you can see the course ID 101 for the mathematics, and the head of the instructor is Dr. Smith. So this shows that in this table the course ID, the course name and the instructors are dependent on the course ID column. So all the non-primary key columns are not completely dependent on the primary key column. So when you take this student name, it is completely dependent on the student ID. So this student name is completely dependent on student ID, but the course name is also dependent on course student ID, but it is partially dependent on the course ID, and also the instructor is dependent on student ID but partially dependent on the course ID. So in such situation we can break down the table into two separate tables. Let's say for example I am going to create student data, keep as only, and here I have to give student ID which is a primary key. Let me copy from here. Let me copy this and paste it here, and I can create another table which is course. In this course table I can just provide the course ID, course name and the instructor. So for this table let me provide the course ID as the primary key, and here you can refer foreign key of the course only table and the course ID here. So now when I create both of this table, so I need to create this table before referring it in a foreign key. So now you can see I have separated the single table into two different tables. So here you can see that the course name and instructor are completely dependent on the course ID, and this student name and course ID is completely dependent on student ID. This is what the second normalization form is. So all the non-key columns are completely dependent on the primary key column. None of the column have a partially dependence on any other column. So here you can use any joins relationship based on this primary key and foreign key and establish relationship for your table and get all your queries in a single result set. So what is the use for doing this? So we are separating both table into a separate single table. So by separating this we can actually reduce the space. So if I have created the course table, so I can just insert values to this course table, insert into course and values. Here I need to pass the course ID which is 101 and the course name along with the instructor. So totally I have 4 courses. So I can just insert 4 rows for my courses table. So by inserting these 4 rows I can avoid using this course name and instructor for again and again in this student table. So in the student table I can just have the student ID and student name along with the course ID. By referring to the course ID I can get this course name and the instructor without using this course name and the instructor multiple times in my table. This can reduce the storage space for me, but when I have a million of records repeating itself, so I can just use this course ID and fetch the course name and instructor from the courses table, then using it again and again in the same table. Also it can be easy for me to edit the values. So let us also see what is third normal form in SQL Server. Here I have a orders table. Let me create this first. So let me take this as order table. So now command executed. Let me copy this name, paste it here. So now let me insert this three values inside the table. Now let us select the value in this table. Here you can see I have a order ID, customer name, product name, quantity, unique price and total price. So from this table you can clearly see the customer name is dependent on the customer ID, the product name is dependent on the product ID, and the unique price is dependent on the product ID. So we can just create three separate tables, which is a table for order details, where you can have the order ID, and you can have the customer ID, and then you can have the product ID along with the quantity and total price. So again we can have another table for our customers. Let me have as customer only. Here I can have the customer ID, which is a primary key, and I can refer this customer ID as a foreign key based on this primary key, and also we can have customer name here. So this is for the customer table, and again we can create another table for this product details. Here we can have the product ID, which is a primary key, and we can refer this primary key in this table as a foreign key, and here we can have the product name, also the unique price for each product. So now you can see if I need to add or modify any customer, I can just use this customer table to modify my rows. So I can update the customer value once in this table. So I have a customer ID, I can just update the customer. So if I need to update a customer name in this orders table, then I need to update all the rows where the customer ID is present. So this will dramatically reduces my times to update the values. So breaking down these tables is also, we have seen like this is the second normal form. So here you can see all the columns are completely dependent on the primary key of the table. So but in the orders detail you can see the order, customer ID, product ID, quantity are completely dependent on the order ID. But this total price is also dependent on the order ID, but it is partially dependent on the quantity, which is a non-ID column. So this is not a non-key column. So when a column is dependent on the non-key column, so this total price is dependent on the quantity, also the unit price. So basically a total price is the multiple of the unit price and the quantity. So in the third normal form we can just take the transitive dependencies. So these things are transitive dependencies. We can just remove this, and whenever you need to calculate those columns you can just add a aggregate functions. So in the select statement you can have select, so you can just join those tables, and in the result set you can just multiply the quantity along with the unit price, and you can take this as total price from the both the joined tables. So the column total price is dependent on the non-key column. So removing such transitive dependencies will also helps us to perform the queries very efficiently and the data storage will be very much easy for us, and it can be easy to maintain our data without any redundancies and duplications. So we have seen what is a normalization in SQL Server. So let us see some examples or uses for the normalizations. So when you use normalization in your table, then you can just save your data disk space. So while saving the column in a separate table will also helps you to reduce the disk space, and your DML operations like insert, update and delete operation will be easier and faster than having the entire data in a single table, and it avoids anomaly values. So when you update the table value, you can just update a single value for your table when it is normalized form. And what is the use of a denormalized form? So what is the use for using a denormalization? So basically, if you don't need to have any adequate transactions, then denormalization will be very much helpful for you to have a better performance in your query. So the retrieval of the data will be so much faster, because there might be any joins used in your tables to relate the smaller tables. So let us also discuss in which use case we can use a normalization, and which use case better suits for the denormalization. The system like OLTP, which is a online transaction processing systems, where the data will be adequately changing, and there might be so many inserts, update and deletion happens frequently. In such databases, the data integrity need to be crucially maintained. For such case, we can use normalization. It will be helpful for you to manage the table, and you can easily avoid anomalies while these DML operations. When your database is a OLAP, which is an online analytical processing, which is a basically a data warehouse where you have stored data which will not data comes adequately, and you need to have a better query performance in such data warehouses for your reporting purpose. So you can have a normalization in your transactional databases like on-prem SQL, and the adequate data changing databases. You can, in data warehouses, you can use denormalization to have a better query performance. So I hope you have understood what is normalization and denormalization in SQL Server. Let me provide the GitHub link in the description. Please find the solution and few exercises. Please subscribe to the channel and watch all the videos in the SQL Server playlist. Thank you for watching.